All right, so we have applications. Oops. Involving right triangles. So I think 9.1 is kind of a review of what we've done already, so we don't want to spend too much time on it. But the ideas are important. So applications involving right triangles. So a lot of this should be very familiar. The only difference now is that the angles we're finding will be at different positions. 9.1 will just tell you that, yeah, they're all right angles, so no worries. So use the right triangle to find sine A and tangent A. Okay, so we're going to give us a triangle. A right triangle, of course. They're going to put A up here. So in the home, we're going to have something like this. They'll give you a picture and give you the sides. So they'll just ask you, all right, what is sine of A? So A is no longer where usually we put it over here, right? On the left. But now we just need to think of sine in terms of its definition. So it refers to any angle that we're talking about. So sine A would be opposite to that angle over the hypotenuse. So opposite is now down here. You see how that's a little bit different compared to usually we would call it like adjacent, right? So opposite is now 15. Hypotenuse doesn't change though. It's always the same spot. Right? Because the definition is opposite over hypotenuse. Tangent of A is equal to opposite over adjacent, right? So opposite is over here, 15, over adjacent, so right next to it, 36. You see how it's still pretty similar to stuff we've done before, right? So the first couple of questions will be something like this on 9.1. Is there any questions about that? So ignore my brother's dog's howling. She likes to howl when she hears the sirens. Like, ambulance sirens, I guess. Okay. Example 2. So on example 2 is going to be similar, but we're going to find every part of the triangle. Okay. Let's see here. Use the right triangle. And give it info. To solve the triangle. Okay. So here I'm just going to give you some information. I'm not going to give you everything. So we got to find the missing pieces. So there's A. We need to find it. B is going to be Let's see here. 7. C is unknown. Little c. Lowercase will be saved for the sides of the triangle. Okay. Capital letters would be the angles. Capital C looks no different, but whatever. Okay. So if they give us, let's say, well, let me think which one I should give you. Yeah, I'll go ahead and give you these right here. 30 and 60. So the right triangle will be, so right here is my A, 60. Over here is my B, which we'll call 30. And that's a right angle. So if that's the right angle, then what does C have to be?
90.
Yeah, it has to be, right? There we go. Okay, so the letters I'm going to put opposite to these angles. So little a would be down here, and I need to find it. Little b is opposite, which would be over here. And hypotenuse will still be C. Okay. So I need to find all the missing pieces. So you need to use the definitions of the sine, tangent, etc., cosine to find them. Okay. So if I want to find A, I can use any of the angles, doesn't matter. But since it's opposite over here, I can just use, well, let me think here. Sine of, yeah, I think tangent would be best. Because tangent would be equal to this side over, so A over B, right? B is 7, so I can have one unknown to solve for it. So I can use tangent to help me out. So tangent of 60 is equal to, right? So there's tangent of 60. It would be opposite to that angle, which is A, right? I don't know what that is, over adjacent, 7. So use the definition to help you out, and once you've set up the equation, just solve for A. So I'm going to multiply both sides by 7 to cancel the fraction. Right? So that means that this implies that A is equal to 7 tangent of 60 degrees. So what is A?
We put that in our calculator.
Yeah, we got it. This chapter will require a lot of calculator stuff.
12.12.
What'd you get?
12.12.
Yeah, that's right. 12.12. Okay, so that's my A. And the homework will tell you to round at the end, but also how many digits to work with along the way. I like to use the exact numbers because there's no rounding. But if I have to use an answer that I have found that has decimals, then I need to be careful. Okay. So right now the missing piece now is little c, right? We got this guy. Okay. So c is a hypotenuse. We could use cosine. We could use secant. whatever. I'm gonna use just. I mean, I don't, it doesn't really matter. I could use sine as well. But I'm gonna choose cosine because cosine is defined to be cosine of A would be defined as 7 over C, right? So I would use an exact number instead of a decimal. If I use sine, I'd have to use the decimal. So I'm not saying that's wrong. You could still use sine. But if I use cosine, I don't have to even worry about rounding because that's a 7 instead of a 12.12. So I will purposely choose to use cosine of A, which is 60, sorry. Let me fix that. Cosine of 60 is equal to adjacent over hypotenuse. And I want to find the hypotenuse. Right? That's the only thing that's missing now. So solve for C here. You can do the cross multiplication thing, or you can just think of it as me taking the reciprocal of both sides and then multiplying by 7. I don't like using cross multiplication because even though I know it's easier, people forget when to use that and what the heck that means, and then it just causes lots of confusion. So let's not worry about that. So all I did was take the reciprocal of both sides, right, and flip them over. Then I'm going to multiply it by 7 like I did up here to cancel the fraction. So from here to here, take the reciprocal of both sides. Just flip them over. And then multiply both sides by 7. That'll cancel my 7 down there. So this implies that C is equal to 7 over cosine 60. What would that be? Approximately
14.
14. Cool. Came out as a whole number?
Yeah.
I like when that happens. That's nice. 14. So that's exact, not approximate. But anyway, you see how we're playing with the definitions of sine, cosine, tangent that we learned chapter 7, maybe, I don't remember, and just solving different parts of a triangle. Okay. Is there any questions about what we did? Or any questions on the algebra?
So basically, you're just the angle you take, and then the definition of adjacent or opposite is how you decide which trig function to use. Correct?
Yeah.
So like cosine is.
Uh-huh.
So like on that one, since 60 is at the top of the triangle, you would use the adjacent over the hypotenuse, and the
Right.
adjacent is the one to the right. Gotcha. Okay.
Yeah. So as long as, I mean, you can use any trig function you want. You can use any angle you want. Just make sure that when you choose them, you don't have two missing pieces, right? Like two missing variables, because then you can't do anything.
If you were to use like the 30-degree angle, then adjacent now becomes the 12.12.
Right.
Okay.
So I could have done sine of 30 and then used opposite over hypotenuse, which would have been 7 over c as well. Right.
Okay.
So that could have been a different route. But at the end, it'll all be the same. So they'll have a few questions where they'll give you right angles, they'll give you different pieces that are missing, they'll ask you to find the sides and the angles. Just remember that the total sum of all the angles has to be 180. And since you're given a right angle, it should be pretty easy to find all three right away. Should be. Okay. All right, let's move on to number 3 then. Okay, example 3. The hypotenuse of a right triangle is 8 inches. If one leg is 3 inches, one leg of the triangle, I mean, find the degree measure of each angle. So here they don't give you a picture, so we got to build it ourselves. Let's see here. So we have a hypotenuse of 8 inches, right? We have one leg equal to 3. I can choose either one because they didn't specify. I'll say A is 3. I don't know what B is, so I'll have to find it using the Pythagorean theorem, right? Or the definition of your trig functions, depending what you want to do. Since they did not give me any angles, let's see here. We do know it's a right angle, so we do have one angle. So let's start writing everything down. Little a is 3. Little b is missing. Hypotenuse is 8. Capital A, I don't know. Don't know capital B. Capital C is still 90 because 9.1 is all about right triangles.
A triangle equals 180, right?
Yeah, the sum of all the angles will always be 180.
Okay.
Sum of all angles for a triangle. Sorry. Okay.
And is that for any triangle, or is it just specifically for right triangle?
For all triangles. Okay, so right now we have, what do we have? We have only that one side. So I want to find A and I want to find B because all they want is the angles, correct? A and B. They said find the degree measure, meaning they want all the angles in degrees. So I don't have to worry about A. I don't have to worry about B technically, because I could get away using my inverse trig functions. Because I have, if I use sine A, even though I don't know what A is, I can solve for it. Sine A would be equal to the opposite side, 3 inches, right, over 8 inches. Now, if I take the inverse trig function of both sides, or if you prefer, use the definition, whatever makes more sense in your head, we can solve for, and these inches would cancel, so just be unitless. Right, this would mean that A is equal to sine inverse of 3/8, which is something. So let's plug that into your calculator. What is sine inverse of 3/8 in degrees?
22.
22 or 22?
22.
Okay. So I'm going to round to one decimal place. So say 22.0 degrees. All right, so now I have A and I have C, so what is B going to be? right? Because we know the sum of all the angles has to be 180, correct?
68.
So yeah, just subtract the ones you know. So you have, it looks like 220. It's supposed to be 22.0. So it'll be 22 plus b plus 90, right? So subtract everything to the other side. B is equal to 180 minus 90 minus 22, which is, you said what was that? 50.
68.
Oh yeah, 68. Thank you. There we go. Do you have any questions about this problem? So you have a few questions where they just give you some information and they'll ask you to find the angles or find everything or maybe just the sides, depends. So you can still use the ideas from chapter 8 where you find the inverse. Use the inverse functions to get an angle. Okay.
Did we need to know what little b was?
No, they only asked for the angles, so we don't have to do it. But we could, right, if you wanted to. Okay. Example 4. Let's do a word problem because you're going to have a few of those. So a tower that is 57 feet tall casts a shadow that is 82 feet long. Find the angle of elevation of the sun to the nearest degree. Okay, nearest degree. All right, so we have to understand what the heck is angle of elevation mean, right? So basically that's like if you're on the ground, let me draw you a picture actually, it'd be better. Let's say you have a sun over here. There's a tower in front of the sun and it casts a shadow, right? So this is 82 feet. This is 57 feet tall. Creates this triangle. So the angle of elevation to the sun. So basically, if you're on the ground and you stare at the sun or look towards the sun, right? I don't advise that you stare at it. You'll have this elevation angle. So when I'm going upward, elevation. This is the angle they want. Okay. Or if I'm looking at the top of the building, I'm looking up here. Does that make sense? So that's what they mean by elevation angle. You also have one for looking below. They have a different term. But does that make sense? What they're asking for? Like, can you tell that they want this one by reading the paragraph?
Yeah,
Yeah.
basically they want to know what angle you have to look up to see the top of the building, right?
Pretty much, yeah. We'll call it A, I guess. Whatever. So I have the opposite side and adjacent side. So what function should I use to find it? Because it's up to us.
Tangent.
Tangent.
Yeah, right? Tangent should be good. So tangent of A is equal to the opposite over the adjacent. So that means that I need to take the inverse tan, or arctan, of both sides. Or use the definition, whatever makes more sense. So that would mean, oops, forgot something. It's tangent inverse of tangent over here. The tangent inverse of tangent. So that means that A is equal to tangent inverse of this number. What is the angle? And tangent inverse of 57 over 82. Let's see. 57 over 82. Looks like 34.8. 0, whatever. So since they said nearest degree, I should round up to 35, right? So this is the angle of elevation. Is there any questions on that problem or 9.1 in general? Okay. Well, that's pretty much all you're going to see in 9.1 is just solve triangles, find the angles, find the sides, do a couple of word problems, and that's it. That's all there is for 9.1. Okay. Let's start 9.2. We get the formulas and then we'll take a short break. 9.2 is called the law of sines. So in this section, we're no longer dealing with right triangles, so we have to use a different formula to help us out. So this works for any kind of triangle. There are 4 cases. The first 2 cases are the ones you want to use law of sines for, because you can't do it. You can't do it on the other 2 cases. So case 1, you're given one side and 2 angles. Are known. One side and 2 angles are known. We call those ASA or SAA. Angle, side angle, or side angle, angle. Case 2. You're given 2 sides and the angle opposite to one of those sides. We call that SSA. Case 3. Two sides and the included angle are known. Case 4. Three sides are known, but no angles. Call it SSS. All right, so for case 1 and case 2, you can use the law of sines. If we have nothing but sides, we should not do law of sines. If you have two sides and one angle, but that angle is not opposite to any of those sides, then you cannot use law of sines. So those are the case 3 and 4. So let me give you the law of sines and the way I'm going to be writing the triangles. One moment. Well, hold on. Let me write this first, and then we'll take a break. Law of sines. So for a triangle, with sides ABC and opposite angles, capital A, capital B, capital C, respectively. Okay. So given a general triangle that looks like this, of course I can't draw very well, but assume this is just some rando triangle. It's not necessarily an isosceles. Okay. So A will be here when I'm doing my examples. C will be here. B will be here. Opposite to these angles would be their lowercase counterparts. Okay. So here's the formula. Sine of capital A over little a is equal to sine of capital B over little b, which is equal to sine of capital C over little c. But also you can write them this way. It's up to you. When you use these formulas, you can basically take the reciprocal, which is better if you want to solve for a side. Just use these guys here.
Can you move the paper?
Oh yeah, sorry. There you go. Okay, so I'm gonna stop, take a break here. It's 8:49. Let's come back at about 7:05 or so. Okay. Okay. So example 1. Solve the given triangle. Okay. So they're going to give me one side. Don't know the other sides. I know that This angle is 100. This angle is 60. This one is unknown. So let's write down everything that we do know. Little a, little b, little c, this 4. Okay, capital A, we don't know. Capital B is over here. Capital C is up there. There we go. So let's see. We will use a law of signs to find the missing pieces. But we need to have, oh, actually, we could find A, right? What's A going to be?
20.
Yeah, it has to be 20. Okay, so we got, all we need is 2 sides and we're done. Remember, you cannot do Pythagorean theorem anymore because this is not a right triangle. So don't do it. I know somebody's going to do it on the test, but I'm asking you not to. It's only for right triangles. So I'm going to look for little a. So I'm thinking I'll
What
set.
The triangle in half.
You could, but then you'd have to solve for that new angle here. But then you would only find half of it. So it depends on the shape. If it's a really weird shape, I mean, again, this is not drawn to scale. This is just a crappy drawing because I can't draw.
Right.
So this side could be like shifted up weird, right?
Yeah.
You know what I mean? But if it wasn't isosceles, you could. You're not wrong, but it's not.
The only reason why I mentioned it is because in the textbook it had said that earlier. I think like in the last test.
Mm-hmm. Yeah, it depends. It really depends. But sometimes you could. But let's go ahead and use these formulas here to find little a. So here we go. So I'll say that I'm going to do it in general so you can see what's going on. So sine a over sine A is equal to b over sine b, right? Well, hold up. We want to use one. Yeah, we don't want to use a and b because those are both unknown. We will use something that is known to find the unknown. Sorry about that. So we will use c over sine c. I'm going to set that equal to one of the ones that are missing. We'll find a first over sine a. Right? So that's the equation right there. I set the last one equal to the first one. Since they're all equal, we can do whatever we like. Right? Set any of them equal to each other. Now find the missing side. I want to find a. So I'm going to multiply sine a over here. So that would imply that a is equal to c sine a over sine c. Do you see the algebra that was done to get there? I skipped a step. You multiply both sides by sine a, right? Do you see? Or no? So we have all these pieces, so you just plug them in, you'll find the a. So basically I made like a formula for you. That's what happened, right? So plug it all in. C is 4. Sine of a, well, we said it's 20, right? Over sine c, which is 100. So what is little a? So plug that into your calculator. Let's see, it's a little bright. Okay, so you can hit alpha y equals to create a triangle, or sorry, a fraction. So you can hit 4 sine 20 sine 100. So that will be little a, 1.38. So let's round to 2 decimal places. 1.39. So 1.39. So now I'll do the same for B. So I want to find B. So B over sine B. I'll set that equal to the one that I know. And that's C over sine C. So do your algebra and isolate little b. B will equal to C sine B over sine C. So just plug all that in and you'll get B. So that'll be 4 sine of 60 over sine of 100. So plug that into your machine. Let's see what that is. 4 sine of 60 over sine 100. 3.51. So 2, yeah, 3.52. Okay, so do you see how the law of sine formula works? Now you can set any of these equal to each other. Use the pieces that you have that are given to find the missing piece. That's all we're doing. And this little double arrow here, I skipped an algebra step. I went from here to there. Okay. Solve. You solve for B. You solve for A. So you can, if you don't want to, well, you have a formula in terms of these sides. But I recommend you set them equal to each other every time and solve for it. That way you don't make any mistakes. Okay, or get confused. Okay. When is your exam due? I forgot. You guys remember? Is it still open or no?
Tomorrow?
Okay, well let's stop here so we can give you more time to focus on your test. So next time we'll finish 9.2 and 9.3. Okay. I kind of feel bad throwing a lot of new stuff on you when you have an exam coming up.